All right, let's dive right into Chapter 2 and get a handle on the different types of data we're dealing with in the world of big data. This is really the core of the whole challenge.
Hey, a quick welcome from Nexus. For all of you in the computer science program, think of this explainer as the next level. We're going to take everything you already know about things like data structures and databases and see what happens when you scale it up. Way up.
So, here's the plan. We'll start by looking at this just data deluge we're all facing. Then we'll jump back to familiar territory, perfectly ordered, structured data. After that, we're diving into the creative chaos of unstructured data, figuring out how to make those two worlds talk to each other. And finally, we'll see why timing can change everything.
Okay, so what's the big problem we're trying to solve here? Honestly, it's that data is coming from everywhere. It's not just sitting in neat little databases anymore. No, it's in every social media post, every click on a website, every signal from a million different sensors. We're literally swimming in a deluge of data.
And this quote just hits the nail on the head. You know, looking at one type of data by itself, that's manageable. But the real magic, and the really tough part, is figuring out what happens at the intersection of all these different types. How does a random, unstructured tweet connect to a perfectly structured sales record? That's where the insights are buried.
Let's kick things off on some familiar ground, especially for anyone who's studied computer science. We're talking about structured data, the world of perfect, predictable order.
And the definition is probably exactly what you're thinking. Structured data is anything that plays by the rules, anything that fits neatly into a model that you've defined ahead of time. You know, it has a schema. If you can picture it in a spreadsheet with nice clean rows and columns, yep, that's structured data.
But even in this tidy world, look at where it all comes from. Machines are just cranking this stuff out. Think GPS data, web server logs, every transaction at the checkout counter. And at the same time, we humans are creating it constantly. Every time we fill out a form, click on an ad, or even make a move in an online game.
And the engine behind all of this, the thing that keeps everything in line, is the good old Relational Database Management System, the RDBMs. It's the system that uses that strict schema to lay out the tables, the fields, and most importantly, the relationships between them.
And here's a super simple example of what that schema looks like in action. You've got a product table and a demographics table. See that customer ID field in both? That's the key. That's the clean, structured link that connects them. This predictable relationship is really the heart and soul of the structured data world.
Okay, time to pivot. We're leaving that neat, comfortable world of relational databases and diving headfirst into the creative chaos of unstructured data. And here's the kicker. This is where most of the data in the world actually lives.
Just take a second and let that number sink in. 80%. All that focus we put on structured databases, that's for just a fifth of the total picture. The huge, overwhelming majority of information that's out there is totally unstructured. It's wild.
So, what is it then? It's simple, really. It's everything that doesn't have a predefined model. There's no schema, no rule book telling it what it should look like. It's just raw. It's messy, it's unpredictable, it's freeform.
And when you put them side by side, the difference is just night and day. Structured data follows a schema. Unstructured data couldn't care less. Structured data fits in nice rows and columns. Unstructured is all over the place. And that means structured data is a breeze for computers to search and analyze, while unstructured data, well, it's a huge headache for traditional tools.
And you are swimming in this stuff every single day. Think about it. Satellite images, photos on your phone, the actual text inside your emails and documents, every single tweet, every Facebook post, every text message, it all adds up to this massive, growing ocean of unstructured data.
Now, it's not totally black and white, of course. There is a middle ground here called semi-structured data. It's not as rigid as a database schema, but it has tags or labels inside it that give it some kind of organization. The classic example is an XML file, where you have tags that tell you this is a name or this is an age.
So now we've got these two completely different universes, the perfect order of structured data and the wild chaos of unstructured data. The huge question, the one where all the value is hiding, is how in the world do we get them to work together?
I mean, that's the real challenge, right? How do you connect the dots between a customer's very structured purchase history and their completely unstructured, rambling product reviews on social media? How do you make these two fundamentally different kinds of data actually talk to each other?
Well, the solution really breaks down into two key parts.
First, you need connectors. These are the special tools that can actually go out and pull data in from all those different places. And second, once you've got the data, you need a way to describe it. And that, my friends, is metadata.
Seriously, metadata is the unsung hero of the entire big data world. It is literally data about the data. Think of it like the Rosetta Stone or the instruction manual that tells your systems what a piece of information is, where it came from, and how it connects to everything else. Without good metadata, trying to integrate anything is basically impossible.
And this table just lays out the whole spectrum beautifully. On one end, you've got structured data, rigid schema, defined format, like in an RDBMS. On the complete opposite end, unstructured, no schema, no defined format, like a photo or an email. And sitting right there in the middle is semi-structured, with its flexible, self-describing format, like that XML file.
Okay, but wait, there's one last really crucial layer to this whole puzzle. It's not just about what kind of data you have, it's also about the timing. The speed at which you need to analyze that data can change the entire game.
See, for some things, you don't need instant answers. Think about quarterly financial reports or long-term marketing plans. You can process that data in batches, maybe overnight or once a week. But for other things, like detecting credit card fraud as it's happening, you need answers now. That requires real-time processing of data that's constantly streaming in, and that demands incredible speed and scale.
And that brings us to the ultimate question. We get the what now, right? We understand the different types and timings of data, but the billion-dollar question is the how. How do you actually build a system that can handle all of this? This immense volume, this crazy variety, this incredible speed, all at once, at a massive scale.
Well, the answer lies in a foundational shift in how we think about computing, a technology called distributed computing. And that is exactly where we're headed in the next chapter. Thanks for joining this explainer.